Network design considerations. Learning objectives and key concepts for this module are: describe common network topologies and network infrastructures, and incorporate them into a secure network design. Key concepts: network design principles using defense in depth, protocols and addressing, intrusion detection systems, intrusion prevention systems known as IDS or IPS, encrypting communications, and endpoint security. Network design and defense in depth. Secure network design embeds core protections and improvements into an IT infrastructure before it's implemented. Design comes from planning. Planning comes from understanding of business needs, user behavior, and network vulnerabilities. The common security goals are the CIA triangle, again, confidentiality, integrity, availability. Also, the AAA, which is authentication, authorization, and accounting, and it also includes privacy and non-repudiation. When considering a defense in depth design, we want to look at the elements of the network design. We want to research, plan, model, and test our designs. Achieving defense in depth through layering. Think of defense in depth as an onion, and as you peel back the layers. Defense in depth is concerns of placement, programming flaws, default settings, maximum values, processing capabilities, memory capacity, backdoors, malicious code, social engineering, and physical attacks. Defense in depth requires multiple layers of defense. Numerous safeguards protect each asset. Defense tools interlock with other tools and overlap to improve security. We try to eliminate single points of failure, or at least identify them, and any element, component, or aspect in the system that could lead to a failure or compromise. And we want to avoid single points of failure. Planning for scalability. Growth can be expected, unexpected, gradual, or abrupt. Proper network design evaluates and predicts potential growth scenarios and plans contingencies for each. One contingency for growth is to build additional capacity into the current infrastructure. Steady, controlled, limited growth is often a method for ensuring long-term viability and stability. While designing our network, we want to work with senior management. Security success depends on the buy-in of senior management. Senior management dictates organizational strategic goals and plans, including IT infrastructure and security, approves the budgets, provides funding, encourages compliance, and supports security, sets expectations for corporate culture, monitors and approves network security design and implementation. But just remember, everyone is responsible for security. Protocols evaluate security designs annually. TCP and IP is generally the primary network protocol. Most networks still use IPv4 over IPv6. Elements of network security are based on the protocol in use. Changing from IPv4 to IPv6 may result in changes in the security environment. If host and software are less than 5 years old, you may upgrade to IPv6 with minimal complications. If IPv4 with IPsec, Internet Protocol Security, still functions well, no urgent need to upgrade to IPv6. Perform rollout of protocol changes in stages. Common types of addressing. Private address, assigned to computers for identification on a network. Internet routing use for numeric IP addresses in packet headers. Packets may make many hops between the source and destination. IPv4 is 32-bit address, and IPv6 is 128-bit address. Public IP addresses are a finite number of addresses available. Issued by the Internet Assigned Numbers Authority, IANA. Controlled at the regional level by the Regional Registry entry. Direct communication with the Internet. required for internet-facing applications. An example of a private IP address would be 172.16.32.10. The 172.16 would be the private space that's non-routable across the internet and falls under the private IP address. A public IP address for this example would be 143.215.50.20. 143.215 is publicly addressed, it's routable, and it goes across the internet. Private IP space, reserved IP space. Class A IP space would be 10.0.0.1 through 10.255.255.255. Class B would be 172.16.0.0 through 172.31.255.255. Class C would be 192.168.00 through 192.168.255.255. These can be reused on internal networks between your home or any other business organization across the world. These are non-routable, they're isolated from the internet, and every ISP and internet provider out there will not route these IP addresses. So that's how we can use them over and over. Need to use network address translation to communicate with the internet, and that is referred to as NAT. Static addressing. Each system is configured with an address. The address remains the same until it's changed manually. IP addresses are managed at the device level. Each system is guaranteed the same address. Making changes can be cumbersome. Dynamic addressing is quite the opposite. It's dynamic host control protocol. Request an IP address from a centralized system. Addresses are leased for a set period of time. Systems may acquire different addresses. Reservations for the same address can be made. Addressing is centrally controlled, and attackers may be able to borrow an IP address. IPv6 accounts for 25% of global internet addressing. Packet headers differ in size and construction from IPv4 addresses. Addresses consist of 128 bits. The types of addresses are unicast, which identifies a single network interface, anycast, assigned to a group of interfaces usually belonging to different nodes, multicast, used by multiple hosts which acquire the multicast address destination by participating in the multicast distribution protocol among the network routers. Does not implement broadcast addressing. Controlling communication pathways. We can do that through the router configuration, encrypted protocols, physical access management, and filtering. Intrusion detection systems and intrusion prevention systems. IDS is an intrusion detection system, and it detects unauthorized user activities, attacks, and network compromises. May be host-based or network-based. IPS, intrusion prevention system, similar to IDS but can take action to prevent a breach from occurring. In other words, IDS is passive and IPS is proactive. Benefits: logical pairing of functionality, reduction of administrative overhead of maintaining multiple devices. Drawbacks: potential performance implications, wire speed, and possible feature set limitations. In this example, we see an IDS system detecting an attack. The attack makes an alert to the operations center or the administrator that's monitoring the IDS appliance through either SMS or email or a webhook. And for them to block that traffic, there's manual intervention on the administrator's part to go in and block that traffic. As you can see in this example, IPS detects an attack, alerts the operators, and then modifies the firewall and router configuration to address the attack. So it does not rely on human intervention, can be automated, and there's positives and negatives on that. You could have a false positive where the IPS detects what it thinks is an anomaly or a signature and proactively changes and stops that attack when it was really a legitimate traffic. So that's a caution you have to be careful of. But that is the advantage of an IPS over an IDS. Placement of the intrusion detection system to get unfiltered traffic for analysis. So in this example, we look, the internet is on our left. We have our internet router, which could be managed or unmanaged, that we manage it corporately, or we have a provider that manages it and gives us the handoff, and then we put that IDS in front of our firewall before the firewall pre-filters any traffic. This design, you're going to get a lot of noise, and that's why it says unfiltered. You're going to get everything from the internet before it hits the firewall, before it's the corporate network. So you're going to have to look through a lot of logs and see exactly what is legitimate and not. In this example, we're going to take the same concept, but we're going to move the IDS from outside the firewall to inside the firewall. This is a better solution. This would allow the firewall to pre-filter anything coming from the internet, so that we're trying to plug the holes in the screen door. Then we have the intrusion detection system, and we're going to get a lot better results and a lot less false positives as it comes into our corporate network. Hardening systems, the process of reducing the attack surface by removing unnecessary components and adding protections. Focuses on improving the security of hosts and nodes. Any weaknesses exposes the entire network. Re-examine all hosts against hardening policies annually. Common hardening recommendations. Remove all unnecessary protocols. That means turn off ports that you don't need. Uninstall all unnecessary applications and services. You don't need an application on a device, uninstall it. Define a complex password for all accounts. Configure account lockout and define logon warning banner. Important thing about a banner is you cannot prosecute if somebody gets into your system. You cannot prosecute if you do not have a banner. Equipment selection. Avoid choosing hardware based solely on cost. Evaluate hardware for native security defenses. Consider vulnerabilities introduced and protection of the security infrastructure, and select equipment that improves security. Security is a cost center, so yes, you want to find the most affordable piece of equipment, but the cheapest isn't always the best, and the most expensive is not always the best. So you need to evaluate the hardware on what it's trying to protect, the services that it's offering, and then consider the vulnerabilities introduced and protection of that security infrastructure. AAA, you'll hear that referred to often in the security business, which means authentication, authorization, and accounting. It provides security, supported and enforced authentication, authorization, and accounting. IAM is identity management. AAA is part of the Identity Management Access. Fundamentals. Security does not exist without AAA. So authentication is, am I allowed? Authorization, what am I allowed to see or do? And accounting, I'm going to track through the network what that user does. Authentication is the verification of identity, username, password, or a multi-factor authentication. Authorization is concerned with what the user has access to do. Least privilege is always best practice. Accounting, logging, monitoring, and auditing the environment to check for security, policy, and compliance. Communication encryption. That process involves encapsulating the intermediary protocols, VPNs or virtual private networks, protocol encryption, and data encryption. For host, we want to look at local host only or hosts that are remote and mobile. Users inside the network, servers, computers inside the network would be local only. Your remote workforce are mobile devices, phones, laptops, stuff like that would be outside of the network, would be part of your remote and mobile domains for remote access, and you would need a encrypted pathway back into the network to allow that traffic securely. Local only hosts should be considered somewhat secure and doesn't need that encrypted communication interior of the network. Redundancy, the act of avoiding single points of failure by building in multiple element pathways and methods of accomplishing each mission critical task. Redundant array of inexpensive disk, or a RAID, as it's referred to, a form of redundancy for hard drives and protects against hard drive failure. UPS, uninterruptible power supply, a form of redundancy for power. Devices provide temporary power in the event of a brownout or blackout, and that's the key word, temporary. UPSs, depending on how they're sized, usually 20-30 minutes while you could gracefully shut down before the batteries run out of power and it shuts down. Communications, redundant communication links for voice and data. How do we connect out to the internet? How do we connect out to the PSTNs or public switchable networks, your phone systems? Other redundant firewalls, proxies, routers, switches, servers, and databases. Endpoint security. When we talk about endpoint security, we're talking about how to protect clients, servers, routers, switches, firewalls, and proxies. Risk assessment and management. Risk assessment examines values, threats, levels, likelihoods, and total cost of compromise versus the value of the resource and the cost of the protection. We need to determine the overall value of the resource or asset. Known as the asset value, this calculation should include both tangible and intangible cost and value. We need to determine the threats that the asset faces. For each threat, calculate the exposure factor, or the amount of potential harm expressed as a percentage. This will create a list of asset threat pairs with corresponding EFs. Calculate the single loss expectancy, which is single loss expectancy equals the asset value times the exposure factor. This is the amount of potential loss that could be experienced due to a single occurrence of compromise against the asset for a specific threat. This will add an SLE value to each asset or threat pair. For each threat, calculate the potential number of times the threat could be a realized attack within a year's time. This is known as the annualized rate of occurrence. To calculate the annualized loss expectancy, we'll use this formula, and this is the amount of potential loss that can be experienced due to any compromise of this asset for a specific threat within a year. This will add to the ALE value for each asset threat pair. Sort the list of asset threat pairs by the ALE. The highest ALE is the biggest risk for the specific asset resource. Take the asset threat pair with the largest ALE and determine the possible countermeasures that could be used to protect against that threat. This creates an asset threat countermeasure triplets. For each asset threat countermeasure triplet, calculate a new ARO. The countermeasure should reduce the ARO. A perfect countermeasure would reduce the ARO to 0, but there are few perfect countermeasures. With the new ARO, calculate a new ALE for each asset threat countermeasure triplet. For each asset threat countermeasure triplet, perform a cost-benefit analysis. Here's the formula. Sort the asset threat countermeasure triplets by the potential cost-benefit. The triplet with the greatest cost-benefit is the best choice. What are zones of risk? Zone of risk: any segment, subnet, network, or collection of networks that represents a certain level of risk. Less risk equals less security. Zones of trust. Highly trusted zones require less security. Zones of low trust require more security. Risk and trust levels of common network zones. We have the local area network, or intranet, the corporate network. The risk level is low and the trust level is high, meaning we trust the inside of our network, and it's a low level risk. Extranet, which is a network outside of our local area network, it's a medium to low risk with a medium to high trust level. DMZ, which is the demilitarized zone, this is where you put your public servers, web servers, and that kind of stuff for the public to look at. The risk level for that would be medium to high, and the trust level is medium to low, so we don't trust the DMZ. Internet, risk level is high, trust level is low. We don't trust anything coming from the internet. That's why we have the firewall for the packet filtering. In summary, we've looked at network design principles and defense in depth. We've looked at protocols and addressing, intrusion detection systems and intrusion prevention systems, encrypting communications, and endpoint security.